I guess I was gone when you guys went college. But for me, it's been like 3 weeks. Like, cause I was born when I'm Thanksgiving break. I know.
Hey, I don't work tonight. See you, I don't.
You don't work tonight?
Yeah, I don't work tonight. I got some night off.
Bring some cash. So then we'll just order the pizza.
Bullies are what is wrong with this world.
What?
Bullies are the reason this world is going to crap.
Ethan, if you wanted to just like.
Jack, remember to bring a couple bucks tonight.
That's food.
Do night.
Why do you guys make this breakfast?
We're gonna order breakfast pizza and we're gonna
Cut it up and put it in stew.
well, we're just gonna eat it in bowls.
We're just gonna put it in bowls and eat it.
Yeah.
Let's put it in like the blender.
If you don't bring money, you cannot eat.
Okay.
If you don't bring money, you can't eat.
Oh yeah.
I mean, because that happens a lot. Like I feel like people buy something.
Wait. Remember that time you didn't put any money into the pizza and you had some?
Yeah, that's what I'm trying to say.
It's just not right.
It wasn't right.
And then Eric was super mad.
Exactly.
And then I was like,
Eric paid for like. I remember one time I paid for like half of it.
okay. The reason I ate some though is because I said, "Is everybody done?" And then everyone's like, "Yeah, I'm done." And then I ate the last piece because it was left over, and then Eric got mad.
I said it was. Jack, come on, order 2 for sure.
Yeah, at least.
2
How
large.
much? $2?
2 large bacon.
Connor wouldn't know. He's never there.
They're probably like 12
Guess
each.
what? I'm gonna be there tonight.
Oh, about time.
You know what? It's not.
You some God in your life.
I do.
If everyone could bring like $3, we'd be
I just
PreCalculus.
I know you're not gonna do
$5?
$5.
Yeah, wait. How much is it?
Give it back.
like 12.
Pizza's
A
$12.
breakfast is 12.
Large.
It doesn't work. The batteries are dead.
Large pizza.
Yeah, let's just say 25. So, yeah, everyone bring
Double
like
A's.
3.
Okay.
All right. I have 2 double A's for you.
Okay. I know, new scene chart. I know, weird. Just go with it. All right. So
Yeah, that's weird.
today, all I want to do is do a quick introduction to the next section today. We're going to do kind of 1 or 2 examples, maybe. We'll see how far we get. It's going to be stuff that it's nice because this section is kind of a little mini review. There's only a few new things we add. Okay, so it's kind of mixing stuff that we've previously done with this stuff. So it's kind of nice to kind of piece things together like what we've kind of worked on. Today, we'll start with this. Make sure that page 336, that's due Friday. I will give you some time today to work on it, maybe 10 to 15 minutes. That's kind of the goal today. But I want to do at least a few notes to kind of intro stuff. Make sense? Okay. Today, we're going to be talking about graphing again. So if you have some graph paper, that I've given you that we can use for notes, it might be a good thing to have it out. It's not necessary, but I mean, it might be one of those things where you get some practice graphing again. We do have a couple things. We're going to talk about end behavior one more time, kind of tell where the tails are going, that type of thing. X and Y intercepts, symmetry, that type of thing. We'll talk about the actual asymptotes themselves. Yes, that is a new term that we're going to talk about today. One of the new terms to talk about is it's called an asymptote, which is a point of undefined for a graph. It's a point where a graph can't cross this like imaginary boundary. Okay? There's a couple different types of asymptotes that we have. We have vertical, horizontal, and slant. The goal today, our main goal, is to intro those today. To give you kind of a rough idea of how to do it. Because it's just like this simple little quirky rule that I look at, and hopefully it makes sense to you once we go through a couple of problems. Okay? Makes sense what we're doing today. So let's jump right in. We'll talk about a couple of these things. So first example today. So let's do a function here. Now it's going to be a little weird. Notice the title of the section. It says rational function. It doesn't say polynomials. It just says a function of some type. If it said polynomials, it would be very strict on the way we can write these. But today we're not. So the function that we're going to be looking at is something like this. It's going to be our function. Okay, now notice, it is a fraction. Agreed? Okay. The thing is, it doesn't really matter. You could divide those things. You could do synthetic division, you could do long division, actually divide them out and see what type of polynomial or function rational item you get. Okay, I'm not really worried about that right now. There is a couple of times we will have to divide this thing. There's a couple of rules we'll have to look at it. All right. Questions, comments about the start of our problem?
Will it make it easier to divide?
It will make it easier for certain rules. Yes, yes. To answer your question. Okay. So let's go through the basics. Let's talk about, some of the things we definitely know. Like end behavior. It's where the tails go. Agreed? Now, how I do this, like if we were to actually look at this problem, do we agree that it's not a polynomial as it sits? Now, the polynomial is easy. If you had a single string of items added and subtracted together, you could look at the highest degree power and figure out where the tails go. You could. The problem is this is a fraction, so it's not in that polynomial state. Now, without dividing, just think about it this way. Okay? Because we could divide if you wanted to. What's the highest degree here? Second power, right? Highest degree down here. First. When you take x to the second, you divide by x to the first. What do you get? X to the first, right? Because what you do is, technically how you do this, like in algebra 2, you cancel out the powers, making that a 1. So, in theory, hypothetically, if we were to divide, probably the highest degree power we'll have in the very end is once we divide, being x to the first. Agreed? Now, even if we did like synthetic division or long division, you get probably something like x to the first, and you keep going from there. So if this is a polynomial, what type of power is on that x? Even or odd? Odd. So that means the tails go different directions. In fact, since I look at out front, my numbers are positive out front. That means it's probably going the traditional way where an odd graph would go. That's my little shortcut. Without even dividing, I can tell that tails are going two different directions. Does that make sense? Okay. So that's kind of like the end behavior on the very, very outsides. Now, that can definitely change the level of difficulty for this problem. But that's the rough idea what we're looking at. Okay? Now, the weird part is about this graph, there is a break in the graph. There's a break in this graph. And that's something we're not used to. Usually our graphs are very flowing, continuous from the left to right side. On this particular problem, there's not. And we need to look at that, and that's one of our things we're going to intro today, and how I know that. Okay, but we can at least get the the outside arrows where we're going. Okay, x and y-intercepts. For x-intercepts anyway, we can definitely do that part. For x-intercepts, how we do this, find the zeros. What you do is figure out where the zeros are, the x-intercepts for my function here. You factor the top apart. So, is the bottom arm? I don't really care about the bottom. X minus 2. Okay, but how do you factor the top? What kind of rule do we have to follow? We have grouping, difference of squares, trinomial, cube rule. Which rule should we do from the top to factor? Now, we look top and bottom, there's nothing to cancel out, so there's no cancellation rules. But for x-intercepts, basically what we're doing is we're trying to figure out how does this thing equal 0 for the y-axis? Like, because this stands for y, right? So I'm going to plug a 0 in here and put it back. The only way that this fraction could be 0 is if one of these top parentheses are 0. Think about that. Because if one of the top parentheses are 0, 0 times anything is 0, and 0 divided by anything is still 0. So what would make the top number 0? -2 and -3. These are my x-intercepts. That's what we're going to do. We're going to hit at -2. We're going to hit at -3. -2, -3. And we know that's what we're going to hit. Okay. Questions, comments about that? Okay. So that's x-intercepts. Now y-intercept. How do we always find y-intercepts? Plug in 0. That's the shortcut. We always plug zeros in for x's to figure out y-intercepts. So again, these are for x-intercepts. That's the numbers we just found. Now for y-intercepts, plug zeros in for all the x's. So that's the difference. So now we're going to plug in zeros here. 0, 0, 0. Right? So that makes 2. That makes 3. When we multiply them together, that's 6. This is a, what, -2 down here. So what's 6 divided by -2? 3. That is my y-intercept. So I'm going to hit at -3. Okay, questions about how we did that? For x-intercepts, you can still figure out the balance pass-through rule, the powers on it. So the multiplicity, that's what we called it. These are powers of 1s. We know we're probably going to pass through this. Probably what's happening is probably doing something like this. Probably doing something like that. Probably what's happening. I don't know how tall that wave gets, but it's probably just passing through both because that's kind of where the tails are going. Okay, now here comes the weird part. Okay, and it's not based on symmetry. Symmetry, we've definitely done symmetry before. Symmetry is plugging in the negative x's, seeing if it's going to be even, odd, or negative, that type of thing. But I'm talking about the actual. Let's jump over symmetry and let's look at the asymptotes on this particular function. Okay. The asymptotes are where graphs are undefined. Graph will not pass over a certain space. The first one is by far the easiest. The vertical. Vertical has one of the simplest rules ever. To figure out where a graph won't cross for a vertical asymptote, like a vertical, imaginary line, basically is what is the one number on this function, if I go back to this original function, what's the one number I cannot plug into this formula? 2. Why not? It makes the bottom 0. You cannot divide by 0 in that math. Agreed? That is a vertical asymptote. You will never touch x being 2. Okay? Because if x is 2, you'll get an undefined number. So at the number 2 here on the x-axis, there is this imaginary vertical line. The graph will never touch it. This is your vertical asymptote. Okay, questions, comments about how we did that so far? How we figured out the vertical asymptote. None of those numbers on 2 will work. Because it makes the bottom 0 and we don't want that. Alright, next. What we look at is the horizontal asymptote. Horizontal is very, very, very basic. Okay? And what I'm looking at now is the powers. Look at the powers for the highest degree. How this works. If the top number, the top power, is somehow smaller than the bottom power, so for the biggest terms anyway, if this is smaller than that, this power, then you'll have a horizontal asymptote at 0. It's just this weird quirky rule that there will be a horizontal line at 0 that you will not be able to touch. Okay? Is the top number smaller than the bottom number for powers? No, no worries there. Are they exactly the same numbers for the power? Because if they are the same power, this is the weirdest thing. To figure out where the horizontal asymptote is, you take the leading numbers out front and you divide them. So if they're the same power for the highest degree, you divide whatever these leading numbers are, and that tells you where the horizontal asymptote is. Okay? If the power on the top is bigger than the bottom, which is our case, correct? There is no horizontal asymptote. We want the top power to be bigger. That's what we want. There's no horizontal asymptote. Okay. Questions with the horizontal? I know there's a lot of rules there. We'll do another one where we actually have to pull them. So that's a horizontal. Okay, now slant is where there's a diagonal line where there's an asymptote. There's this imaginary line where you will never hit this certain spot on this graph. How it works: the top power has to be bigger than the bottom. Do we agree that the top power is bigger than the bottom power? And the second rule: it has to be bigger by 1. So what's the bottom power? 1. What's the top power? 2. You agree that it's 1 bigger. There's a slant horizontal line here where my graph will not touch the certain particular line when we draw. And that's what we're going to look at right now, how we find that. And it's this weird, quirky little thing. And this is the part that I was asked earlier. Are we going to have to divide these? And this is where we have to, on this particular problem. We're going to have to long divide or synthetic divide. Which one do you prefer, synthetic or long? Synthetic. Let's do synthetic. Okay. So we're going to synthetic divide this problem. Now, this bottom number, what number does this represent? Because that's what we're dividing, right? What number does that represent? 2, right? So that goes in the little box. The numbers going across the top are 1, 5, and 6. I'm going to synthetic divide them to figure out what remains. This will help me figure out where that slant, the slant asymptote will be. So drop the first number straight down, multiply by the number in the box, add straight down, multiply by the number in the box, add straight down. So we did get a remainder because I know we didn't divide them equally. We already knew that earlier, how they canceled out. And what we're left with here is a polynomial, agree? It's like this weird little quirky thing. We're left with, this is my constant number, this is 1x, and that is my remainder, which is 20 over what we divided by. Okay? So, that's what we get when we actually divide this. Okay? That, what you're looking at right here, what this thing is, that thing right there. Notice I didn't circle the remainder. I'm looking at the part in the front, the 1x plus 7. When you divide, that item right there, and this only works if the powers are off by 1, and the top power has to be bigger. When you divide and you get to that part right there, the 1x plus 7, that is your horizontal, or not horizontal, but slant asymptote. That number right there. That thing right there is the equation for the slant line. It represents this. Y equals 1x plus 7. What type of equation is that you've seen since algebra class? Since algebra 1. What formula is that called? Slope-intercept form. A slope-intercept form of the line. Okay, that's what it is. It's got a y-intercept of 7. The slope is going up 1 over 1. Up 1 over 1. So at positive 7, 1, 2, 3, 4, 5, 6, 7. There is this imaginary, and again, this is an imaginary line, where we're going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. There's this imaginary line that my graph will not cross. Like that. So now we're starting to put all these little pieces together. Now, to figure out where the rest of this thing goes, because if you agree, there's a bunch of breaks in this graph. Agree? What you need to do to figure out the rest of it is plug in a couple numbers around here. So maybe we'll plug in like the number 1 here to see kind of where this graph is going. We'll plug in like the number, what is this number? 3? We'll plug in 3, kind of see where this thing's going. I'll plug in, we can plug in a positive number way out here, like maybe 10. See where that thing's going. It should be going up. And we can kind of see where the rest of this thing goes, and I can fill it in. Does that make sense? So we're getting a sense for like where the tails are, where certain graphs are, where breaks. I can tell you right now, is this graph symmetrical? No. There's breaks in the graph. It's not symmetrical. That's why I put it up here. Why I waited till later. It's not perfectly balanced right now. We can see it. Now, you see how complicated this is getting now. We have lots of pieces now. You know, just figure out x-intercepts. That was one of the things we've been working on those last couple sections in here. That was what we've been working on page 336, finding zeros to something. You know, finding all the numbers that work. Because maybe this top thing is not factorable. If the top thing wasn't factorable, figure out x-intercepts, what do you think we have to do? The homework you just did. Just find potential roots, figure out which ones work, and graph. So it's like putting everything together. We'll do one of those tomorrow. But let's keep going here. I want to finish this problem. This will be our kind of our last problem that I want to finish with here. Okay. So the first number I want to plug in. Now we figure out x-intercepts, y-intercepts. We figure out the slants, the horizontals. We figure out everything. The only thing we have left is kind of finish off where these tails are going and all that good stuff. So the next number I want to plug in. Let's plug in like the number 1 here. I need to figure out if this tail is going kind of down, where it's going. I'm going to plug in the number 1. This will tell me what my y numbers are. 1 squared plus 5 times 1 plus 6 divided by 1 minus 2. So we know it's going to probably be negative. Does this bottom number turn out to be a negative 1? So top is 1 plus 5 plus 6. What's 1 plus 5 plus 6? 12. That turned out to be a negative 12. So 1 was down here at negative 12. So do you see that it is going down? So our graph is somewhat correct so far. Okay. Now let's plug in like the number 3 here to figure out where this thing's going. I'm hoping 3 is kind of going down this way. That's what I'm hoping for. Okay, so we're going to plug in the number 3, kind of see where this tail's going. Hopefully it doesn't go back up. It shouldn't. There's some arrows up here we should cross. Okay. So let's plug in. Now it could be this weird gap up here. That'd be weird. See, it's way up here. This tail just has to be going up. I don't know where it's going to actually cross. Ooh, that could be weird. All right, so let's plug in 3. Let's see where we're at, because maybe that tail needs to be above those intercepts. Let's plug in 3. So 3, 3, and 3. All right, so the bottom is 1, so that's kind of nice. 3. The top is what? 9 plus 15 plus 6. What is that? 15 plus 15. That's 30 over 1. So that's 30. So it looks like at 3 we're at 30. So yeah, so I'm probably, what's happening is probably doing something like this. So this little, this little gap here, I was squeezed in between. Because I knew that one tail had to be going up. I just didn't know where it was. So that makes sense. And then now if I plug in like 12, plug in 12 here, that should hopefully justify it. That should hopefully, 12 is way down the road. So that should hopefully tell where this tail is going, that direction. So if I plug in a 12, that's 144, that's a 66, that's 10 on the bottom. Yeah, so it's a crazy big number. So I'm probably up there. You see how I'm putting all these pieces together? I'm trying to figure this out. Now, if we actually graph this on a graphing calculator, it will. Jackie, do you have your graphing calculator? You want to type this in? How do you type it? Go to the Y function on your calculator. It's that top left button. Type this in, but I want you to put this top in parentheses. So put a parentheses. Type in x squared, so you have your little variable key. And the little square key. Plus 5x, plus 6, close the parentheses.
How do you do that? I don't know.
she zoomed up to be like 100 by 100, so she zoomed way up. So it is given the correct measurement by hand. She zoomed up. All right. So as you can see, we're doing a lot of stuff here. You know, kind of looking at where the graphs go. Okay, you have the rest of the time today, which is like 10, 12 minutes. As we get up 13, 14, something like that. 10, 12 minutes. You can work on your page 336. I'll give you some time tomorrow, probably a little more time. Tomorrow will be focused more on this to get more of a handle on it. This day was in. Okay?
You brought it?
You tried it. You tried it.
It's a long time ago.
What page?
Hoping that might be an example day. I'll look back and see.
Oh, yeah. So that's not gonna happen, right?
How far did you
Well, right now I'm only
I really want to tell my story.
because we're so close to getting that. Marco,
Patrick.
I'll show you.
It depends on how long you
I
I thought he wrote it like, he threw the ball up after. I was like,
They tell us take a picture of each of the answers on this board.
Say it again?
Brothers we sent to you.
I'm telling him like,
What do you teach?
Patrick DeMarco. Take a picture of the book.
I do it all the time.
Well, exactly.
I do it all the time.
I always take a picture of the answers.
You better not. Wait, is that
have to get 750. Your book, Lord.
oh,
Yeah.
I didn't know if there was such a thing.
you talking about?
How old is this? No, this is like his last week.
except for batting, I do on that.
Then all we're gonna do is just like long base.
On base and batting.
That one isn't until like March.
No, I think it's like, these ones like those more.
Yeah.
You look at those ones, there's like
Yeah.
now it's close. Yeah, so it's like Ron's Belmont.
Renamo?
Brad,
You missed it. I go to Bryce and I go, Bryce, Brianna just walked past. Bryce starts shouting Brianna through the hall. I'm like, oh, what?
He scored 3 points.
I died.
And then,
Did that work out easier?
Bailey's brother.
Oh, that's
yeah, this is state high joke. Close, right? Where's DC Moore? You know? What does it have over? Does it have they're only like 2.5.
Because when the JV got a cold set sheet before he's running it through your mouth. I bet I was not happy.
He told my dad he had like 15 seconds left. He had the ball, and I caught it open. I thought he passed me around. He really went down. He wants you guys to score.
Sure. Just do it with that. What you're doing is you're breaking down the function slowly. Because you already found one, right? So, since you already found
gonna have Saturday.
Probably.
Yeah, North Union.
I don't have to get a, I don't even have to go to ACT. Because I'm not
Oh,
gonna
either.
None of us will.
My dad's not gonna be there.
Why?
He has to go to Kansas City. Why?
So that'll be.
No Saturdays.
Like, there's a gun to your neck, like, you have to do it.
Yeah. it's called
Really?
Horizontal.
Like this Saturday?
Yeah, this Saturday.
Oh, that means we're not having Saturday then.
Rob said go.
But yeah, but it's still 30 minutes.
He chased all that and around the gun. No, yeah, whatever, shut up.
But you know what I'm saying?
No, don't talk to me. No, don't talk to me.
Told me this.
Every- Yeah, these two people are your fate.
Just right as it's
Sitting next to Riley on the bench is a treat. That kid is hilarious. He talks crap about other players. Yeah. They talk crap about people on Earth, and that's just stupid.
Third rat.
Yeah, what a rat.
He's gonna get a T.
Oh.
He's gonna get screwed. If he got a T, he'd probably like miss a game.
Oh, no, I just got to
Get hilarious, though. You said he played on the oh no, he played on Schroeder.
Yeah. Okay, so we're playing Untitled in our best game right in front of us.
Oh, yeah, because that's when we went.
And then he,
one. You're at 1 again and 0?
That's
1, 0, 2? Or not?
Yeah.
It took me like 20 years to do this.
That's what he said.
Okay.
But he's still not me.
Sure.
the
And
ref
Ref
turns
goes,
around.
I heard that. We were all like, very good.
I'm not trying to.
And then we were talking to Colby about how he had to shaft that game.
I go out.
And then Cole was complaining. And then I was like, how come Jody never takes a shaft? And the ref turns around. That's your problem, not his. It's so funny.
Hey, Jack, what Colton said?
It was, because we made him sit at the end of the bench.
Oh,
Yeah.
Do you remember that one game?
Riley.
And then he's like, how come Jody never has to tell me
Still
that?
yesterday, you know?
And then the ref turns around, because he was listening to our conversation the whole time. The ref turns around.
What kind of pork?
And he goes,
tenderloin?
so that's your problem, not his.
Yeah, me too.
The tenderloins are amazing. That
What?
beef would one be like probably go by itself.
How many of us are there?
What are we talking about? That's for lunch. Pork.
I don't know if there's a word, or a number.
Yeah, I hope it's
I never a word.
But we have sea lunch today, Connor, so go let us know. Whenever we have B lunch, whenever we have B lunch, they're like, no, we don't have enough for C. And then every time we have C, they give it away.
I don't know why they would do that.
Completely comes in jingles every
I mean, I like it.
I know we got it.
That's so awesome.
Yeah, you're welcome, right?
Next year, I'm going to see that.
You're so awesome.
Next year, I told who was my lunch group, I'm gonna take the bare minimum of classes and see my periods.
Do you think I should
You want to start with 1 day, you want to start with 9 days first,
He's
right?
asking too much.
Before you do
Yeah, but
that.
if you miss the 10 days, you don't. You get kicked
Right?
out.
Is it more negative?
Dale's version 2.
Probably.
15.
Well, yeah, because Hay made him drop.
Jackie did that for Scott.
Drop all of your
There's gonna be no matter what the time.
just to catch up.
Holy
It's
cow.
probably much more to do than
Unless
this.
I mean, I get it.
I wonder what they're doing too, because those are all credits for to graduate too.
Electives don't mean as much as core classes.
But there's
Alright, yeah.
credits also don't mean the same thing. I mean, like graduating high school.
Yeah, no.
He's missing out on.
Which one have you tried to get this for, right? All of them?
She's starting to get.
Someone has to trust more.
Well, it's only 4, there's 1, 2, 1 and half, right?
I don't know, I'm trying to figure out what a password is.
I mean, I can.
Okay, take so. I'm down because it's gonna be. She's gonna be gone and it's gonna be Mitchell.
Sorry, you take social.
We need to leave this stuff.
Next year? Not next semester? That's not cool. Star, I can't take that class without you.
Thanks a lot there.
You sit on the other side of the room, Bob.
Yeah, but we taught. We had direct line of sight. They read a book out loud.
Oh, I try. I'm on half.
I'm thinking about it. I don't really know how they work. Those too.
You should have tried to tell how it's out there.
What?
There's a negative
Social operative class.
Don't worry, Jeremy's in next year, or next semester, so.
Wait, what?
Jeremy.
John, I don't know why you did
Got
that.
negative
You're
half.
You like shop class. Super easy.
Let's see.
Fundamentals carpentry. We're supposed to go out to the house one time. We've done it for the whole semester.
Jody, you want to take one next semester?
Yeah.
No.
She honestly
Okay,
was
good. It's super.
Yeah, she honestly was good.
You would get to there with all
I think I
fresh.
should
You get to like
actually do
those
stuff
whatever
for
you
class
want.
one.
Not as much with one.
Okay, guys, this is how you cut wood. Like that. And now do it. What? Right? That's how it goes.
Yeah, you can be successful.
Yeah, you're ready to go.
Yeah.
Wait, what?
She assumed you touched her.
She assumed it was gonna hurt.
You can't talk to her now. She assumed. She assumed that's what touched her. No, that was her. She assumed what touched her.
Oh my God, you're good.
I'm not hiding anything on this check. I'm not hiding anything on Vicky's.
That looks like a lace.
Ah.
It's not. It's something that.
We were all ready to go, you know, mentally prepared. Yeah, so then he goes, we're doing it. So we go do we did 4 stations and I pulled out. Yeah, I don't know, we were all like, why don't we just gonna roll up like it's Wednesday? Like, we're all like mentally like ready to do it and everything, like, so we were standing there, he's like, what are you doing?
I'm a coward.
I should have like continue on that homework, you know. So, yeah, I didn't get any of